Welcome to this video on electricity generation and the national grid. We will cover how electricity is produced at power stations and how it is delivered to our homes. This video walks you through three key areas: how electricity is generated, how the national grid functions, and important tips for your GCSE Physics exam. The big idea in power generation is that something spins a turbine, which then drives a generator to produce electricity through electromagnetic induction. While the energy source varies, the mechanism remains the same. Common ways to spin a turbine include high-pressure steam, wind, or fast-flowing water. Once the turbine is spinning, the generator uses electromagnetic induction. A coil of wire rotates inside a magnetic field to induce a voltage and produce alternating current. Understanding electromagnetic induction is vital for your exams. Remember to explain the process using terms like conductor, magnetic field, and induced voltage. Fossil fuel power stations are non-renewable. They burn coal, oil, or gas to heat water, creating high-pressure steam to drive the turbines. The energy chain in a fossil fuel station starts with chemical energy in the fuel, which transforms into thermal, kinetic, and finally electrical energy. Fossil fuels are reliable for on-demand power, but they come with significant environmental costs, including greenhouse gas emissions and acid rain. Nuclear power stations also use steam to spin turbines, but they do not burn fuel. Instead, they rely on the process of nuclear fission to release heat. While both use steam, the key difference is the heat source: combustion for fossil fuels and nuclear fission for nuclear power stations. Nuclear power offers a reliable, low-carbon energy supply, but it presents challenges like high construction costs and the long-term management of radioactive waste. Wind turbines offer a different approach. There is no heating of water involved. Instead, the kinetic energy of the wind directly turns the rotor blades. Wind energy is renewable and has low running costs, but it is intermittent. The output depends entirely on whether the wind is blowing. Finally, hydroelectric power stations harness the gravitational potential energy of water stored in a reservoir, releasing it to spin turbines as it flows downhill. Hydroelectric power is both renewable and reliable, providing quick responses to demand changes without carbon emissions during operation. However, the flooding required can impact local habitats and communities. This table is excellent for your exam revision. It highlights the differences in fuel sources, conversion methods, and the environmental impact of various power station types. Once electricity is generated, it must be transported. This is the role of the national grid, which acts as a vast network to deliver power across the entire United Kingdom. The national grid follows a three-step journey: generation at the station, transmission at a high voltage across the network, and final distribution to homes at a safer, lower voltage. Transmitting at high voltage is a crucial concept. By increasing the voltage, we decrease the current, which significantly reduces energy waste through heat in the transmission cables. For full marks in your exam, remember this three-part answer. Describe the high voltage, the lower current, and finally, the reduced heat energy loss in the transmission cables. Transformers are essential for changing voltage levels. Note that they rely on electromagnetic induction and can only function with an alternating current supply. Step-up transformers are located at power stations. They boost the voltage from the generator, often up to 400,000 volts, to make long-distance transport more efficient. Step-down transformers are found at substations. They reduce the voltage in stages as it nears your home, ultimately providing a safe 230 volts for your appliances. Here is a quick summary comparing the two types of transformers. Remember that step-up transformers increase voltage to reduce current, while step-down transformers do the opposite. This diagram captures the full journey of electricity. Being able to explain each stage and the reason behind it is a fundamental requirement for your physics exam. Transformers work by inducing an alternating voltage in the secondary coil. A changing magnetic field in the iron core is created by the alternating current in the primary coil. You may need the transformer equation in your exam. It links the primary and secondary voltages to the number of turns on each coil, allowing you to calculate the output voltage. In the UK, we use 230 volts at 50 Hz for our homes. This standard level is designed to be high enough for our appliances to work, but low enough to be safe. Lastly, be aware of energy losses. While rare, losses occur due to resistance heating in cables, inefficiencies within the transformers themselves, and, at extreme voltages, corona discharge. Let's look at the broader picture of electricity generation. Our choices directly impact the environment, the reliability of the supply, and the total cost. The UK is actively shifting toward renewable sources to meet these needs. The national grid uses both overhead and underground cables. Overhead lines are cheaper and easier to access, though they are visually intrusive. Underground cables are hidden and preferred in sensitive areas, but they are significantly more expensive and difficult to repair. Now let's test your knowledge. Can you recall the process for generation, why high voltage is used, how transformers differ, or what separates nuclear from fossil fuel stations? These are classic exam topics. Here are a few more practice questions. Remember that transformers only work with alternating current. Wind power uses direct kinetic energy, and nuclear power provides reliable energy without carbon emissions, though waste management remains a key challenge. To wrap up, remember that turbines drive generators, high voltage transmission minimizes heat loss, transformers adjust voltage levels, and every energy source has unique trade-offs between reliability and sustainability.